and welcome to Badger Talks Quick Picks, which brings exciting happenings, resources, and talent from your UW flagship campus to the people of Wisconsin and beyond. I'm Natalie Chin from Superior, Wisconsin. I'm the Climate and Tourism Outreach Specialist with Wisconsin Sea Grant. I'm pleased to introduce Titus Seilheimer, who will take us through a fish's view of 20,000 years of Great Lakes ecology. The Great Lakes were geologically speaking under ice very recently, so how did their ecosystems develop? Taking the perspective of the collective memories of lake trout, Dr. Titus Seilheimer will tell the story of the development and change of the Great Lakes ecosystems and food webs. You might not look at the lakes the same way again. Titus is a widely trained and experienced Great Lakes aquatic ecologist who specializes in fish habitat and ecology. He grew up in the Chippewa River watershed of northwestern Wisconsin, studied biology at Lawrence University and McMaster University, and has more than 20 years of experience in Great Lakes science. He lives in Manitowoc, Wisconsin with his family and enjoys paddling on Lake Michigan and pedaling his bike around the local country roads. Please welcome Titus Seilheimer.
Thank you, Natalie. All right, so I'm going to jump right into this and try to cover a lot of time in a short, quick pick. So we are going to take a journey around the Great Lakes. So just to give a perspective here of what we're talking about, these are the Laurentian Great Lakes. Really an important global freshwater source, 20% of all the surface freshwater right here in these 5 lakes. I love this picture just because it shows kind of the whole region, but also you can see off to Cape Cod and the curvature of the earth there into space. And really, it's these systems that I work on all the time and that are really important to Wisconsin that also have a long history, but also a short history. So we're going to talk first about kind of how the Great Lakes were formed and how does that shape the lakes and the ecosystems that we have today. So I think many of us are familiar with the Laurentide ice sheet's role in coming down from the north, carving out many parts of Wisconsin, including the Great Lakes, and really forming the state that we know today. So it's really an icy history. And, you know, we're talking 20,000 years, but a lot happened in that 20 to 30,000 years in recent times. So a graphic that I really like from the Wisconsin Geological and Natural History Survey gives a perspective of, you know, starting at 31,000 years ago. And, you know, even as recent as 21,000 years ago, all the Great Lakes completely covered in ice and really kind of the maximum extent of ice cover in the region. And then 18,000 years ago, down on those bottom graphs, up to even 13,000 years ago, half of Lake Michigan under ice and all of Lake Superior under ice fairly recently. So, you know, that can kind of start our clock. And also, I like to think about, so we've got those times, recent complete ice cover, but also it's a matter of time. You know, I think we are thinking about climate change a lot today. And this is another example of climate change because we had a cool period. The glaciers moved from the north to the south. And we also have this great graph showing that time period. And there were, you know, between D, E, and F, there were some pretty big advances and retreats. And that, you know, happened over a relatively short amount of geological time. But, you know, kind of a perspective to think of when we talk climate change and in the future later on, we're still talking thousands of years from like 16,000 years ago to 13 or 12,000 years ago. So a lot of, you know, still thousands of years compared to now when we're talking about changes happening in decades to centuries. You know, where did the fish go? I think that's, you know, because we had lots of these systems before the glaciers advanced. And, you know, there were existing ecosystems before the formation of the Great Lakes as we know them today that would have shifted out of the path of the ice and moving south. And these are the refuges, things like the kind of Mississippi River refuge, the Missouri River refuge, along the Atlantic coast refuge as well. So these were areas that weren't glaciated in the most recent maximum advance, but were areas that a lot of our fish species that went on to form the Great Lakes ecosystems we know today, like the lake trout, would have been able to kind of hang out in, waiting for that ice to clear out. And then they could move into and discover and kind of colonize these new systems, the Laurentian Great Lakes that we know today. This is a map that I think is really informative for us in Wisconsin, even though it's focused on kind of what were the refuges for the province of Ontario's fish. But being in Wisconsin, kind of being with the driftless area and the Mississippian refuge, I think we're in a good place to use this as lake trout kind of were able to move from the refuge into the Great Lakes. And then where did they go after that? As the ice continued to recede to the north, really over thousands of years, you can see kind of the light green in this map showing this shifting of ice and also these different glacial lakes that occurred over that the kind of last 13,000 years. So Lake Agassiz, covered a massive part of the Canadian country and, over northern North America into Lake McConnell, and then connecting up into what we know today as some of the Canadian Great Lakes. So Great Bear Lake, Great Slave Lake, and actually the dots here looking at a type of cisco, which is kind of a relative to the trout. And so these were all connected over this 13,000 years ago, which allowed for fish to move between the glacial refuge at that maximum period all the way up to the far north in Canada. And if we look at a species like lake trout, we can actually see in this time diversification. So, these, I think the message here, these are relatively young lakes. And even though they're pretty young in the, less than 10,000 years in some cases, they did have time for these lake trout to move in and diversify and start filling in different niches. So what we're actually looking at here, you can, see these pictures of what look like very distinct fish, but are all lake trout. They're all Salvelinus namecush, but they are forms. They're kind of these adaptations in different waters to different conditions. And in the Great Lakes, we have 4 different forms in Lake Superior, a siskowet, which is sort of a deep lake trout, humper, which is kind of a smaller one, redfin, a little bigger, but inhabiting kind of similar habitats to the humper. And then the lean, which is the fish that you would go out and catch if you were on a charter fishing trip out of Bayfield, Wisconsin. We can also see kind of a closely related another group that filled in those habitats in the Great Lakes, but also into the north. And these are the deep water ciscos, as well as the cisco artidi. So on top there, that's kind of also known as the lake herring. But even within the Great Lakes, we saw great diversity of these closely related species, to the point where even in the last couple of years, argument as to are these even different species or are they just artidi forms that kind of look different and use different habitats. The most recent science here is that these are different species, and we are seeing, sort of this diversification that happened over the last recent time period. So I want to zoom in now into the Great Lakes and really look at the changes that have happened over the last, say, 500 years, starting with the historic food web. So really, historically, Lake Michigan, if we went back 500 or 600 years, lake trout on the top of that food chain, that food web, burbot kind of, which is a freshwater cod, but also a top predator. So we're looking at the species on the top. Our next level is our kind of forage fish. So we have all those ciscos that I just showed, the lake herring or cisco there. And then we have a lot of different benthic and pelagic species. We've got algae down on the bottom, abundant lake whitefish, and lake sturgeon swimming all over the place. So this is kind of our where we're at historically. And we have people. We have people living on the shores of the Great Lakes, living in the area we call Wisconsin now for thousands and thousands of years, and really the importance of fish to the peoples that lived here. So this is actually an old image. Well, it's not an image. It's a kind of a woodcut print, I think, and showing the local indigenous peoples in Sault Ste. Marie area. So in the St. Mary's River Rapids between Lake Superior and Lake Huron, out there, and they are, up in the bows of their canoes, dip netting out lake whitefish for their own use, for subsistence, but also for trade, with the sort of abundant, new arrivals to the region, the voyageurs coming in for fur trading early on, to the expansion of kind of, the colonies into the new states of America, and with the kind of associated harvest. This another kind of woodcut here showing pulling in a commercial net, because people coming into the region bringing these kind of expertise and fish harvest and feeding the expansion of the Great Lakes, populations of people. And also, always worth noting, I think, is that you could, get in a boat in Buffalo, New York, and sail all the way to here in Wisconsin and Milwaukee and Green Bay and Chicago down in Illinois, which was a lot easier way to get to the, kind of the center of the country at that point, or the far west of the country, than it would be through the land before there were roads, before there were railroads. And so these food webs really changed over time. They were really impacted by this settling and development of the region. And from the book Fishing the Great Lakes and Environmental History, 1783 to 1933, which really covers what kind of the rise and fall of the commercial fishery in the Great Lakes, Margaret Beatty Bogue really identified these 5 impacts on really leading to the decline of the fisheries. And certainly overfishing, under-regulated fishing was a big piece of that, which I think, fairly early was able to be managed. But, things like dam building for power, for running mills, impacted the ability of species to move, the alteration of habitat, both in the water and on the watersheds, pollution, the assumption that we could just dilute things out, send it into the water, and invasive species, which I think are interesting in themselves. We can kind of tell these interrelated stories from the perspective of a lake trout. So we had the arrival of sea lamprey, and they're a North Atlantic species, but we're able to move into the Great Lakes through canals. They attach to fish with that mouth you can see there, rasp a hole in the side, and then are able to suck out the blood and fluid. So for us in Lake Michigan, by the 1930s, sea lamprey arrive, and by the middle of the 20th century, we're essentially out of lake trout. They've been eliminated from Lake Michigan, and that allows another North Atlantic species, the alewife, to really take off and boom in populations, making up 95% of all the fish biomass in the lake, and leading to kind of 2 different ways of managing that, developing a commercial fishery and stocking fish, Pacific salmon specifically. So what the alewife fishery looked like, it was, this very abundant fish species, but low value, so 1 to 2 cents a pound, but being used for things like pet food and oils for oil-based paint. And at the same time, the state of Michigan saw an opportunity to create a new sport fishery, and looking to the future, where sport fishing would be more important than commercial fishing. They went through a number of different analyses looking at different species. First started stocking coho salmon in 1966. And quickly after that, stocking Chinook salmon, both Pacific species, and leading to kind of a change in how fish are managed in Lake Michigan, because you have a whole food web without any top predators at that point, and also efforts to kind of in tandem restore native species like lake trout and brook trout. These are just Wisconsin numbers stocking fish, these little young fish into the lakes to help build these populations, and a long history of lake trout and brook trout. Brook trout kind of tapered off, and then a shift really to these other species. Coho salmon and Chinook salmon, very important. Steelhead or rainbow trout in the yellow bar, and brown trout as well, kind of coming over from Europe. But really building a fishery based on these new species to the Great Lakes. So kind of ending up today, I think we have those same bubbles, but we have a more sustainably managed fishery. And at the same time, we have kind of these impacts on aging and obsolete dams. So they're still there impacting species, and they're needing to be removed. There's also, habitat is still all, it's been alteration, and we've got pollution, new sources of pollution, and then we've got invasive species as well continue to be a problem. And I think as we move into the present, we can look at, what are some of the stories of some of these invasive species. So we have, this is kind of our food web, we're revisiting it, but now we're looking at Lake Michigan today, and we've got our different non-native species like our sea lamprey and our alewife, which had come in through those canals. Then we have our ballast water introductions, round gobies, zebra and quagga mussels, the invasive water fleas. And then we have our intentional introductions that we maintain today, the salmon and trout up on the top, as well as rainbow smelt that were intentionally introduced in the 30s. What are the consequences of having some of these different food webs? Well, we have very clear water, which sounds like a great thing. But when we look at why is Lake Michigan so clear, it's really the driving force of these quagga mussels, which are, filtering the water, and they're very dense. You can see the zebra mussels on top here were essentially replaced by their cousins, the quagga mussels, and quagga mussels really having densities much higher than zebra mussels ever did. If you want to look at just an example of what this might look like, from the perspective of big fish and little fish, we've got our quagga mussels here filtering. You can see that little siphon on the left side of that mussel. That's where it's drawing in that water. It is removing that phytoplankton, so clearing the water. That means there's less food for those zooplankton, those little crustaceans that might be food for the prey fish, which means there's less food for prey fish and they can support less. But at the same time, we continue to supplement our top predators by stocking these trout and salmon, and ending up with kind of a limited population of prey fish out there, which we can see looking at decades-long trends of decline to really low levels of things like alewives with bloaters as well. If you can see that little orange band, that's the round goby, which is actually not sampled well by this USGS survey that we see in this graph. So, definitely a picture of the lake changing, and kind of in the last decade or so, sort of trying to balance the predators with the prey and with the changes to the food web. So just to close things out, to look to the future, I think it's important to think about climate and consider that climate has really impacts all components of the Great Lakes ecosystem. Everything is related to climate, whether that's things like water temperature, and we are already seeing increases in surface water temperature. This is where we're at right now, looking back in time. So especially places like Lake Superior seeing rapid increases in water temperature as that surface water warms and becomes stratified and warms up even faster. So we are already seeing these trends that can carry over into winter, and we've also seen declines in the amount of ice cover as well. So this is definitely a concern. A lot of fish species that might spawn in the fall rely on that ice cover to protect their eggs over winter, things like lake whitefish. And as ice cover declines, that is not going to protect those eggs, but also could impact the availability of good ice for ice fishing. So people can't get out on safe ice. They're not going to be able to have that enjoyment of the lake. Also, shifts in phenology. I'm just showing a few different examples as a food source that you might see. And phenology is about timing. Is the timing changing if we have earlier springs, if we have changes and more intense rainfall later on in the season? That can change things. So I think there is kind of uncertainty here as we look at the future, but we can support resilience in the Great Lakes. Being kind of, thinking about how can we be more resistant to change when needed, but also build more resilient ecosystems and habitats looking to the future, and looking at maybe adaptation also a solution, and then accepting that some things are going to change and we probably need to look for new options into the future. So I think it's a combination of these four different kind of mindsets, looking to the future and having a Great Lakes fishery that is sustainable and really out there for people to enjoy. So with that, I'd like to thank you for making it all the way through this talk. And certainly if you have any Great Lakes questions and fish questions, let me know and shoot me an email, and I'm happy to discuss it. Thank you.